Hi, good to see you again. Welcome to Block 2, Developing Geometric Reasoning, Lesson 7. I'll share my screen. So, in your previous lesson, you learned how to use knowledge of geometric facts related to triangles and quadrilaterals to solve some interesting maths problems that would otherwise be seen as complex maths problems. In today's lesson, you're going to learn to solve even further complex maths problems, angle problems, by pulling on those geometric facts that you already know. Remember to like the videos, subscribe to the channel, share the videos with those you think can benefit, and click on the notification bell so that when new videos are released, you will be notified. By doing so, you help us grow our global mission to provide a platform where children, regardless of their economic circumstance, can have access to high quality maths education. Thank you. Before we start, I would like you to pause the video and answer these retrieval practice questions in 3 minutes. You can work at your own pace. You can use 3 minutes. You can use 5 minutes. It's all up to you. Assuming you've paused the video and you've answered the retrieval practice questions, here are the answers. Let's discuss them. So for the first one, the answer is 2x and 9. But I would like to make a few comments here because this is a skill that we practiced a long time ago, I think during term 1, if not term 2. So to simplify this, remember you collect like terms. So not the way I am collecting like terms. I circle the sign next to the item I wish to collect. In this case, the items I'm collecting are the terms that have X in it. So I have these ones. So not the way I've collected them. So if I rewrite the X's, I'll have 4X. So positive 4X is the same thing as 4X. Add 3X and then subtract 5X. 4X add 3X is 7X. Subtract 5X. That gives you 2X. And then not collecting like terms, you have the 2, you have the 5, negative 5, and you have the 12. All right, so if you rewrite this, you will have 2 add 12 subtract 5. Or you can write 2 subtract 5 add 12. You get the same result. Okay, so your answer will be 9. Okay, so your answer is 2x. This one is 2x. And then this is positive 9. Add 9. Here, remember how to solve equations. You subtract 24 because your aim is to make the x stand on its own. So you subtract 24 from both sides because whatever you do to one side, you have to do it to the other side. So I'll carry on from here. So you have 12x, 180 minus 24 will give you, that's 6 there. We'll carry 1, and 6, that's 5, and that's 1. So 12 divided by, next you divide by 12, and your answer will be 13. Okay? For this one, whenever you have letters on both sides of the equation, always start by trying to eliminate the lowest letter. Now, in this case, if you compare 4x and x, the lowest letter is the x. So it means we have to subtract x from both sides. Okay, now we have 3x. We're now left with 3x. Subtract 15 equal 96. And then we add 15 to both sides. That's now gone. So we're left with 3x equal to 111, and then we divide by 3, which will give us 37. Let's do some new learning for this lesson. How would we calculate the size of angle ECD? Well, have a think. First, we have to identify angle ECD. Remember, the middle letter tells us the location of the angle. So if we start reading the letter E, C, D, we'll see that the angle we're talking about is the angle that is right here, that is in the vertex of these line segments. So line segments CE and line segments CD. So it is the angle between these two line segments. So the middle letter tells us the location of the angle. And you can see it right there. Okay, what other information do we have that we can use to start to solve this problem? What else do you see in the diagram? What do the hatch marks tell you, these hatch marks? Well, these hatch marks tell us that we have an isosceles triangle. Remember the properties we've learned about geometric shapes. So for isosceles triangle, we know that the base angles, that is the angles at the base of the lines where we have the hatch marks, must be equal. So it means that angle there should be 30 degrees as well. Well, what other information do we know about the sum of the angles in a triangle? Because if we have that information, we should be able to find this angle here. And perhaps we could be really close to finding the angle ECD. We know that the sum of the angles in a triangle is 180 degrees. So if we add 30 to 30 and this angle here, we'll get 180 degrees. Another way of thinking about it is if we subtract these angles from 180 degrees, we will get this angle here. And that is why we have got 120 degrees. So 180 degrees minus 30 degrees, add 30 degrees will give us this angle here, which is angle A, which is the angle between line segments AC and CD. Now, what other information do we know that can help us find angle ECD? Well, we know that these are adjacent angles on that straight line. So we can do 180 degrees minus 120 degrees to give us 60 degrees. Why? Because the sum of the adjacent angles on a straight line is 180 degrees. And that's that. Okay, what about this one? If we're asked to work out the size of the unknown angles, how do we start? Well, the only number we're given here is 310 degrees. But what do we know about the sum of angles at a point? Well, we know that the missing angle, when we include it to the angle that we know, will give us a full turn. And we know that a full turn is 360 degrees. So to get the angle that is missing, we can simply do 360 degrees minus 310 degrees. And that gives us 50 degrees. But have a think. What other information do you know or can you see in the diagram that can help you get some other missing angles? Well, we can see these hatch marks. That tells us that this is an isosceles triangle. And we know that for isosceles triangle, the base angles must be equal. So it means that angle should be 50 degrees as well. What other information do we have that we can use to find some other angles? Well, we know that the sum of angles in a triangle is 180 degrees. So if we subtract these two angles from 180 degrees, we would get this angle, which is 80 degrees. What do you know about lines that cross like this? Straight lines. Well, I'm sure you remember that vertically opposite angles are equal. So this angle there should be 80 degrees as well. What other information do we know about the sum of angles in a triangle? Well, first, we know that this mark here, this notation represents 90 degrees. So it means we have two angles known in a triangle. So we can find the other angle by subtracting this angle and this angle from 180 degrees. And that will give us 180 degrees minus 90 at 80 degrees, which will be 10 degrees. It's now time for you to practice what you've learned. Pause the video and answer question 1 in 3 minutes. You can take longer than 3 minutes, doesn't have to be 3 minutes. Assuming you've paused the video and you've answered question 1, here are the answers. Let's discuss them. So for question 1, you were asked, work out the sizes of the unknown angles. All right. And you were also asked to give reasons for each stage of your working. So A is 71 degrees. Why? Because vertically opposite angles are equal. B is 46 degrees because angles in a triangle sum to 180 degrees. So to get B, what we simply have to do, because this is already known as 71 degrees, we can do 180 degrees minus 71 degrees minus 63 degrees. That gives us B. Next, D is 43 degrees. Why? Because angles on a straight line sum to 180 degrees. So to get this, you simply do 180 degrees minus 137 degrees. Now that you know that this is 43 degrees, E will be 43 degrees. Why? Because angles in an isosceles triangle are equal. Base angles, not just angles, base angles in an isosceles triangle are equal. Now that you have that information, you know this will be 43 degrees, and this is also 43 degrees. To get this angle, you simply do 180 degrees minus 43 degrees and minus another 43 degrees. And that will give you the missing angle F. Why? Because angles in a triangle sum to 180 degrees. Let's do question C. So for question C, you will ask for G, G is 51 degrees. Why? Because angles around the point sum to 360 degrees. So to get this angle, you simply do 360 degrees minus 309 degrees. Now that we know that this is 51 degrees, we can find this angle. We know that this is a 90-degree hatchmark or 90-degree notation. So angles on a straight line sum to 180 degrees. So we know that H is 90 degrees because to get H, we simply do 180 degrees minus 90 degrees. Now that we know that this is 90 degrees, to get I, we'll simply do 180 degrees minus 90 degrees minus 51 degrees. Why? Angles in a triangle sum to 180 degrees. Let's look at some new example for the lesson. So this is the second part of the lesson, some new learning. Here we asked to work out the value of A, but there are no numbers. I want you to have a think. How can we get this started? Well, remember that we have an isosceles triangle. You can see these hatch marks here. And what do we know about isosceles triangles? We know that the base angles would be equal. So that angle there should be 3A minus 22 as well. And what else do we know about the angles in a triangle? We know that the angles in a triangle will sum or add up to 180 degrees. So we can start to write these expressions like this. So 3A subtract 22, add 3A subtract 22, add A equal to 180 degrees. Now remember what we did in collecting like terms. It's very important you do it whenever you have expressions all mixed up like this. So we have that one, we have that one, and we have that one. So we have, if we were to rewrite this, we have 3A, add 3A, add A. That's 7A. If we were to collect the numbers, we have that one, and we have that one. So we have negative 22 subtract 22. So when we finish, you would see that the expression would simplify to 7A subtract 44 equal to 180 degrees. Now remember, you have to solve this equation. So we have to add 44 because we want A to stand on its own. So the thing that is preventing us at the moment is the 44. We add 44 to the other side as well, because whatever you do to one side, you have to do to the other side of an equation. So you're left with 7A equal to 224. Next, to make A stand on its own, you divide both sides by 7. So A is equal to 32. It's now time for you to pause the video and practice the rest of the questions. So pause the video and answer question 2 in 5 minutes. Assuming you've paused the video and you've answered question 2, here are the answers. Let's discuss them. So for question 2, A, B, E, and F, here are the solutions. So I'll discuss them and then you can check your answers later. So here we know that this is 131 degrees. So to get this angle here, we have to do 180 degrees minus 131 degrees. And that angle will give us, just a minute, that angle will be 49 degrees. So here is 49 degrees. Next step we'll do to get P, we'll do 180 degrees minus 84 degrees minus 49 degrees. So when we do 180 minus 84 minus 49, that gives us 47. Here, we know that this is 90 degrees. But if we can find this angle, then we can find that angle. So step one, we do 180 degrees minus 90 degrees minus 34 degrees. Now, if we do that real quick, 180 minus 90 minus 34, that will give us 56 degrees. So this place here is 56 degrees. Now you can see that we have these adjacent angles on this straight line. So if we do 180 degrees minus 56, that gives us 124 degrees. This one here, we have this angle here. We want to find this angle, but we're going to have to, go around doing this in a different way. So if we can find this angle, then we should be able to use the sum of the angles in a triangle to find this angle and then subsequently find that angle. So if we do first step one, 180 degrees minus 128 degrees, that will give us 52 degrees. Now that we know that this is 52 degrees, we can find this angle because we can do 180 degrees minus 52 degrees minus 71 degrees. So we can do 180 minus 71 minus 52. That gives us 57 degrees here. Now we can see that these angles rest on this straight line. So we can do 180 degrees minus 57 degrees, which will give us 123 degrees. So we did, to get L or T, 180 degrees minus 57 degrees. For this one here, we know this angle is 52 degrees. You can see these hatch marks here, which mean that this is an isosceles triangle. So this angle should be 52 degrees. Well, we can do this angle because if we can find this angle, then we can use sum of angles at a point to find that angle. So we can do 180 degrees minus 52 degrees minus 52 degrees. So if we do that, 180 degrees minus 52 degrees and then minus 52 again, that will give us 76 degrees here. Now we know the sum of angles at a point is 360 degrees. So if we do 360 degrees minus 76, that will give us 284 degrees. Let's now review answers C, D, G, and H. So let's rub these off. Okay. So for this one, I'm just going to make comments and then you can check the answers by yourself. So here we have these equilateral, this is an equilateral triangle. So all the angles are 60 degrees, including that point there, which means that to get this angle, we can simply do 180 minus 60 degrees, which will give us 120 degrees. For D, we know that this is 41 degrees. We can see these hatch marks here, which means this angle is 41 degrees as well. Now, to get this angle, we can do 100 and we can do 180 degrees minus 41 degrees minus 41 degrees. That will give us this angle here. Now, to get this angle, whatever result we get from here, we'll subtract that from 180 degrees to get this angle here. To get this angle here, we'll do 180 degrees minus 122 degrees to give us this angle here. Now, you can use the sum of angles in a triangle to get angle S. You can do 180 degrees minus the angle that you got here and minus the angle that you got here to get angle S. For G, we know that we're going to get vertically opposite angles. So we're asked to find angle V. So we're going to get vertically opposite angles. So we know that this will be 49 degrees. We know that that will be 72 degrees. Now we can use sum of angles at a point, in a triangle to get this angle. So we do 180 degrees minus 49 degrees minus 72 degrees to get this angle. And then we know these are vertically opposite angles. So whatever we get here will also be equal to V. Here we can see this hatch mark here. But first we can see that this is a vertically opposite angle. So this is going to be 25 degrees. Sorry, my pen is moving. Okay, this is going to be 25 degrees. Now, we see these hatch marks here, which means this angle here will be W as well. So if we add these angles, we're going to get 180 degrees because this is a triangle. So if we have W, add 25 degrees, we're going to get 180 degrees. So now our equation will be 2W add 25 degrees will be equal to 180 degrees. We subtract 25 from both sides. We'll now be left with 2W will be equal to 155. And then when we divide this by 2, we'll get our answer that we have right there. Okay. All right. Pause the video and answer questions 3 and 4 in 4 minutes. Assuming you've paused the video and you've answered questions 3 and 4, here are the answers. Let's discuss them. For question 3 and 4, here are the answers. We'll just discuss them real quick. I don't want the video to be too long. So this is going to be the same angle as here. So this is going to be 70.5 degrees. Now, you can use sum of angles in a triangle to find this angle. So you do 180 degrees minus 70.5 degrees minus 70.5 degrees to get this angle here. Now you can see that we're going to now know these two angles put together, because whatever result we get from doing this calculation, we can add it to 87.2 degrees. And then whatever we get, if we subtract it from 180 degrees, we're going to get angle C, and that's going to be 53.8 degrees. Let's talk about B. Here, we know that this angle, to get this angle, we're going to do 180 degrees minus 99.9 degrees. And to get this angle here, we're going to do 180 degrees minus 115.6 degrees. Now, once we have these angles, we can use our knowledge of the sum of angles in a triangle. So we'll do 180 degrees minus the angle we have here minus the angle we have here. This should give us the angle here. And that angle will have to be equal to angle D because they're vertically opposite. And that will be your answer. Let's talk about question 4. Here you can see these hatch marks. But before we even discuss the hatch marks, there is something else that is interesting that we can see. We can see that these angles here and this angle here will have to be equal. You can see these hatch marks is telling us that we have an isosceles triangle that is placed on its side. So it means this angle here will also be the sum of this angle here, which is x add 48. Now, if we do that, if we know that this will be x add 48 degrees, because these are the base angles of this isosceles triangle, and you can see the hatch marks. When we write this, we'll have x at 48 degrees plus x at 48 degrees at 37 degrees, which will be equal to 180 degrees. Now, when we simplify this and solve, we would get x equal to 23.5 degrees. Pause the video and answer questions 5 and 6 in 4 minutes. Assuming you've paused the video and you've answered questions 5 and 6, here are the answers. Let's discuss them. For question 5, you know that this is 61 degrees. So you've been told that this is an isosceles triangle. So if it's an isosceles triangle, it means this angle is 61 degrees. Now, the next step is you'll do, to get this angle, you'll do 120 degrees. The next step is you'll do 80 degrees minus 61 degrees minus 61 degrees to get this angle here. Now, the next step is to do 180 degrees minus the angle you got here. Someone else might have thought that the angle here would be 61 degrees. So they would be thinking it's an isosceles triangle the other way around. That's why it's possible to have two different answers. All right, let's look at question 6a. For 6a, you are asked to form and solve equations to work out value of x in each of the diagram and to show each step of your working. Now we know that this is a quadrilateral and the sum of the angles in a quadrilateral is 360 degrees. So what you would have starting from here would be 3x, add 6x, add 20 plus 20, add 5x, add 5x plus 17 equal to 360 degrees. So you remember to collect like terms. When you finish solving, x will be 17 degrees. Here, we know the angles will add up to 180 degrees, the sum of angles in a triangle. So we'll have 3x plus 4, add 4x plus 19, add x minus 7 equal to 180 degrees. When you collect like terms and solve, when you finish, your answer will be 20.5 degrees. And here is question 7. Pause the video and answer question 7 in 3 minutes. Assuming you've paused the video and you've answered question 7, here are the answers. Let's discuss them. So for question 7, ABCD is a kite. You will ask A, estimate the size of each angle in the kite. So ABC will be 90 degrees if you remember our properties of kite. 90 degrees. BCD will be 100 degrees. CDA will be 70 degrees. And DAB will be 100 degrees. So remember, for a kite, these opposite angles are equal. So if that is 90, you can estimate that to be slightly larger, and then you can use the sum of angles in a quadrilateral, which is 360 degrees, to get that one. Then you ask, given that P is equal to 20, write a possible expression for the size of each angle in terms of P. All right, so we can say 90 degrees is 4P at 10, and you can have several examples of how to write these numbers in terms of P if P is 20. And that brings us to the end of our lesson. So you have used your knowledge of geometric reasoning to answer complex angle problems. Well done for sticking around and for taking your learning seriously. Until next time, take really good care of yourself, and bye-bye.